Hello everyone, my name is Kubindran Analakithamsle and I represent Group 6 Furious 5 who would like to present our findings for the group project. So basically the title for our project is the Torrance Refinery Explosion from ExxonMobil, and my group members are Logiswaran, Rohini, Tanvir and Sitinur Khaliza. So this is the outline for today. So I'll be starting off with the introduction, followed by the hazard in process industries, and lastly we'll be ending with the problem solving and decision making. So basically for the introduction, the ExxonMobil Corporation was developed on November 30th, 1999. And for starters, ExxonMobil basically focused on chemical-based products such as artificial rubber, catalysts, synthetic automotive oil-based stocks, and many more. Besides that, once further developed, ExxonMobil also started to produce jet fuel, diesel fuel, and also LPG, coke, and sulfur as well. And the Torrance plant of ExxonMobil is actually the second smallest refinery worldwide. And it also covers around 750 acres with more or less of 650 staff and 550 contractors working in that plant. So this is the event timeline for the explosion. So the actual explosion took place on February 18th. However, the timeline initially started on February 11th. So what happened was basically one of the expanders in the plant actually experienced severe vibration problem, and the following day what they did was they cleaned the expander blades because they thought that the catalyst buildup was causing it, so they removed the catalyst buildup. However, the following day the expander had a similar problem, and this time they cleaned the blades, but unfortunately it did not reduce the vibration. So what happened was on February 16th, the process flow through the expander was increased, which caused the vibrations to become worse. It became worse until it reached a high set point, and also the FCC unit automatically shut down into the safe park. So what this caused is that the catalyst which was inside the expander did not form a protective barrier, and also the steam flow into the reactor is basically only a barrier to prevent the hydrocarbon from entering the air side of the unit itself. And the following day on February 17th, what they did was the ExxonMobil personnel decided to reuse the variants which was developed for the 2012 expander entry. However, what they did not do is that they did not technically review these particular variants for the 2015's operation process. And on the day of the incident, which was on February 18th, the workers at ExxonMobil, what they did was they attempted to open the flange on the outlet of the expander in order to reduce the pressure buildup. But what they did not expect is that the steam to escape from the flange, which also caused air to enter the flange at the same time. So what happened is that the hydrocarbons managed to mix with the air, which also formed a flammable a flammable mixture, which then ignite into the expander. And lastly, the explosion debris damages the FCC unit itself, and it also nearly hit the settler tank containing high amounts of hydrofluoric acid and other substance as well.
So, hi, I'm Khaliza will proceed for the hazard in process industry as a mobile refinery, Torrance, California. So, net is the types of hazard that consist in the accident, which are fire, explosion, toxic release, and also physical. Basically, fire can be produced from the electrical sparks or known as one of the ignition sources. And this plant is very high potential to produce fire due to the process that we use to separate particles in electrostatic precipitator. And for the explosion, actually it happened due to the black flow of the hydrocarbon into the reactor, where the hydrocarbon will be mixed in with the ignition sources, which is the spark, and then produce the explosion. And for the toxic release, actually, due to the explosion, some of the debris of the ESP, or known as electrostatic precipitator, actually has found near to the FCC and also acceleration unit, where there might be some of the toxic chemical, which is known as hydrofluoric acid, will be released. And due to improper installing the blades at the reactor, is the main of the factor of the toxic of hydrosulfide will be released to the surrounding. And basically, due to the accident happen, actually there are 4 of employees were injured, and due to the toxic release, it will be endangering nearly to 150,000 residents due to chemical release. So next is, as you can see here, this both data actually can be consist from the Aloha software, and basically for the IDLH, we refer for immediate dangerous to life or health, where actually, as you can see, hydrofluoric acid consists the lowest, which is at 30 ppm compared to the hydrogen sulfide, and this actually very dangerous. If you inhale the chemicals, it might can cause you death or also serious injury. As you can see on the bottom of the table, hydrofluoric acid notes that this chemical is very dangerous, as it also can react with the water or water vapor. So that's all for my part.
Perform process hazard analysis on ExxonMobil-Torrance Refinery facility. Identifying dangers and hazards is basic for guaranteeing a safe design and operation of a system or unit in process plants. Process hazard analysis are fundamental for the assessment of the consequences of incidents, for the assessment of the risks involved, and for the selection of the most appropriate preventive and protective systems. Two of the types of process hazard analysis that we are going to perform today are fault tree analysis and event tree analysis. For the fault tree analysis, as we can see from the diagram, the explosion or the ignition of the ESP has occurred due to both air flowing from CO boiler fans and the leakage of hydrocarbons through the eroded SCSV through the air side of the FCC unit. Existence of airflow are due to valves left unshut and no installation of blinds on top of the main column. On the other hand, hydrocarbon leakage eventuates as SCSV is eroded by long use and as the operator reduces steam flow rate. For the event tree analysis, the initiating event considered are the large vibrations from the expander, which is denoted using A. Identifiers B, C, D, and E are used for different safety functions as written on the table. As we can see from the diagram, we have a possible number of consequences where cross resembles runaway and circle resembles safe continued operation or shutdown. HAZOP case study has also been performed on the Torrance Refinery, specifically on reactor and regenerator, where the parameters are similar, but for different guide words, deviation, possible causes, and actions are found out. Similarly, HAZOP case study has also been done on expander and on gas catalyst separator. For the HAZOP case study on gas catalyst separator, the parameters chosen are flow, temperature, pressure, reaction, separation, and impurity and maintenance, where each of these will talk about the deviation, the possible causes, and the consequences with the recommendations. So, for the protection systems and adequacy, the minimum adequacy required for the protections of such chemical plants and to prevent the hazards from reoccurring, protection systems should be used. Protection systems include valve shutdown as process is hindered, reactor shutdown, and installation of blinds. Stronger physical protection devices such as dikes, relief devices, and clothing should be used. Detectors should be used to check for any leaks inside the unit itself, and proper maintenance and operation should be done for the optimum production without any hindrances.
Assalamualaikum and hi, I am Rohaini. So I will continue on the plant operation system. The process of FCC unit began by feeding the reactor with heavy hydrocarbons, which then mix with catalyst. As the feed travel up the reactor, the heavy liquid hydrocarbons are converted into lighter hydrocarbon vapors. At the top of reactor, the lighter hydrocarbon vapors are separated from catalyst and then flow to the main distillation column. Meanwhile, the catalyst falls down from the side of reactor, through a slide valve into the generator. During the reaction, a layer of carbon called coke, which forms on the catalyst, must be removed. In the generator, the coke on the catalyst is burned off with the addition of air. Finally, the catalyst is fed back to the reactor through slide valve and the cycle is repeated. On the other hand, it is critical that the flammable hydrocarbons in the reactor do not flow into the air side of FCC unit because it might create an explosion. This is due to the presence of electrostatic precipitator (ESP), which locate in the flue gas system. The ESP removes small catalyst particles by using static electricity and will create sparks, source of ignition, when being re-energized. Due to the hazard potential, the system used two slide valves connecting the reactor and generator to maintain the catalyst barrier between the equipment. The refinery system had implemented a safety shutdown system called SafePark, which automatically activates when an expander suddenly vibrates forcefully in the FCC unit on the day of incident. During the SafePark mode, the flow of hydrocarbon into the reactor is turned off automatically, and then the flow of air into the generator is also stopped. The two slides connecting the reactor and generator are closed to ensure the catalyst barrier maintained, and the steam is then forced into the reactor to prevent hydrocarbon in the main distillation columns to backflow, and the ESP is remain energized during the safe park mode. However, due to the function failure of one slide valve, which had eroded over 6 years of operation, the system cannot maintain a catalyst barrier in the reactor. The valve failure had allowed hydrocarbons to flow into the air side of the FCC unit and then causing the explosion to the refinery. The Chemical Safety and Hazard Investigation Board report conclude that the explosion happened due to improper procedure of unit operation. The slide valve, which acts as the critical safeguard within the system, was degraded by the responsible personnel. This also indicates that the SIS or the safety shutdown system do not establish properly by the process safety management. The lack of robustness in the process safety management system have caused the operation of FCC unit without pre-established safe operating limits and criteria for shutdown. And lastly, the refinery relied on safeguards that could not be verified and reused a previous procedure deviation without sufficient hazard analysis of the current process condition. That's all from me. Thank you.
So now we are moving on to the layer of protection of ExxonMobil-Torrance Refinery. So now let's see the available layer of protection at the incident place. So the first layer is spent catalyst slide valve, which controls the spent catalyst flow into the regenerator. The next is regenerated catalyst slide valve, which controls the flow of the hot catalyst to the reactor riser, where it contacts, heat and vaporize fresh heavy hydrocarbon feed to begin the cracking reaction. Next is safe park mode. This is the mode where the control system automatically begin emergency shutdown to transition the unit into a idle state due to any hazard or disturbance in the process unit. And also the occurrence of the explosion is not caused by the inability of the layer of protection installed in the refinery, instead the weakness in the ExxonMobil-Torrance refinery's process safety management system. This explosion occurred during the maintenance of an expander in the process unit, where the overall system was in safe park mode. This explosion could be avoided if the refinery personnel acknowledge this situation, as the overall process unit should be shut down before the maintenance work starts. So what are the improvements should be done? The layer of the protection of refinery was not the cause of this explosion, but the negligence of the higher authorities. The refinery personnel should be more aware of the conditions of the process unit, and a regular checking of equipment should be done in order to make sure the equipment is in good condition. The employer should document that equipment complies with the recognized and generally accepted good engineering practice, and inspection and testing procedure should follow, and that the frequency should be consistent with manufacturer's recommendation and more frequently if determined to be necessary by prior operating experience. The higher authorities should be responsible immediately to a report made by their employees, come up with a solution as soon as possible to avoid any consequences which can lead to fatal. They also need to review the safety procedure and make sure that they are compliant with the new legislation.
So for the next part is process operability. The practice of plant maintenance is to accomplish the least number of failures, malfunctions, and to keep the plant in great working conditions at a minimum cost. Plant maintenance system also ensures the accessibility of the machines, services, and buildings. Machines and facilities should also be kept at their ideal working capacity to be utilized to make the most profit with no interference. Now, for the startup of chemical plant systems, they include the whole plant system to be flushed for any residuals or debris inside tanks, pipes, or any part of the inline systems. The feed quality and quantity is to be checked, re-verify, and test all inline sensors, test for set points of interlocks, timing relays, and alarms. Purge all air out of the system at low feed pressure and check system for leaks. For plant shutdowns, on the other hand, have two practices: to fix issues discovered during past major shutdowns, to investigate portions of the plant not available during operation, and discover problems that will be fixed during future plant shutdowns. Now, the Torrance Refinery used to conduct scheduled maintenance and inspection, and in fact, the accident occurred due to maintenance work. So the practice of plant maintenance system in Torrance Refinery. This is what we are going to see. But the steps that occurred in this that caused this explosion has started with catalyst. Now, catalyst buildup formed on the blades of the expander, causing large vibrations. Unsuccessful maintenance work done to clean the blades, triggering safe park mode. Spent catalyst slide valve is closed but eroded due to long use. Catalyst leak into the regenerator through eroded SCSV instead of forming a protective barrier or on SCSV. Operators decide to open flange, isolate the expander, and install blind. Steam started to flow out of the flange. Management decided to reduce steam flow rate, which no longer prevented the leaking hydrocarbons to mix with air side. Thus, leaking hydrocarbons and air mixed to form a flammable explosion in the ESP. Operators increased steam flow up the reactor riser significantly, but late. So that's why the hydrocarbons had effectively entered the air side of the FCC unit and were streaming towards the ESP already.
So now let's see the problem solving and decision making that had been done by the refinery personals. First, the process troubleshooting. The key factor that contributed to the flammable mixture accumulating inside the ESP on the day of the incident is ExxonMobil relied on indirect operating parameters to measure critical safeguards for the safe mode of the operation. They relied upon operating parameters did not signify that the FCC unit was in danger condition leading to the incident. In addition, ExxonMobil had not developed a safe park procedure for how to safely operate within specified safe operating limits. ExxonMobil relied on a variant that has been developed in 2012 without verifying that the safeguards specified in the variants were sufficient. Erosion damage that had developed over 6 years of operation likely compromised the SCSV, and it could not maintain a catalyst barrier while the FCC was in a safe path mode. Steam flow to the reactor has been reduced, likely causing a pressure deviation that leads to leakage of hydrocarbon to enter the flue gas system. A leaking heat exchanger in a slurry oil pump around allowed light hydrocarbon to enter and pressurize the main column to a higher than typical pressure. ExxonMobil did not shut down the FCC unit when it was identified that the SCSV leaked and had not established a catalyst barrier. The expander could not be effectively isolated while the unit was in safe park. ExxonMobil opened process equipment without conforming to refinery standards, and the ESP remained energized when hydrocarbons enter the flue gas system, providing an ignition source to trigger the explosion. Next is the decision made and the precautionary steps implemented after the event. The refinery has implemented protective systems that prevent ignition of flammable gas, including hydrocarbons not in the presence of CO, inside of the electrostatic precipitator for each mode of operation. The refinery personnel required identification of all safety critical equipments, consequence of failure for each mode of operation, and ensure safety critical devices can successfully function when needed. Torrance Refinery will be required to perform a risk evaluation to identify the safe consequence of the extended operation. The Torrance Refinery also created a siting risk analysis performed of the FCC unit and electrostatic precipitator and implemented appropriate safeguard to minimize the consequence of the electrostatic precipitator explosion.
In conclusion, as you can see here, safety at working area is very important as it will be impact toward our health as a worker and also people surrounding. For the poor management, improper process design and also lack of safety training towards the worker will actually lead to the incident happen. In order we want to produce any plant, we need to have a proper management and also give a lot of training, especially for the safety training to our workers, in order we want to avoid any accident to be happen. That's all from our group. Thank you so much for listening.